We're going to graph using multiplicity of roots. Given the function 4x times x plus 2 cubed times x minus 1 to the 4th power, we're going to use multiplicity of roots to graph this, and that's equal to our f of x. Now, we already had the degree listed as 8. Why? Because 4 plus 3 plus 1. It's just the sum of the exponents. You have 4 plus 3 plus 1. Then we should list the y-intercept. And the y-intercept is, well, it's what happens when you let x be 0. So when I put f of 0, when I put 0 into the function, this is equal to 0. Then we should list the x-intercepts. 0, negative 2, and 1. It's simply what's in the opposite sign of what's in the parentheses, or if the x is outside, then it's automatically 0. Then let's list the multiplicity of each of these zeros. Alright, so now let's list out the multiplicities. 1 has a multiplicity of 4. Negative 2 has a multiplicity of 3. And x has a multiplicity of 1. Has a multiplicity of 1. And we are going to use this information now to help us graph. Alright, so now we are going to graph this. And the zeros are at 0, 1, and negative 2. And the degree is 8, and that means that both ends are up. That means that when we come down to our first 0, we have to make sure that we're coming at it from above, because that end has to be up. So we'll do that, and then when it comes to this 0 here, because it's got an odd multiplicity and it's 3 or more, it's going to do that a little bowing effect. You'll see if you graph it on a graphing calculator. And then we should figure out how far down to draw it. So go f of negative 1. And why am I choosing negative 1? Because that's between negative 2 and 0. And that's equal to a negative 16. So we're going to go down to negative 16, which is down here. Well, and it's going to go like this. And then it's going to go through this 0, and it's not going to bow because the degree is 1. But see, it went through the odd degrees. And then we should figure out how high to draw in between 0 and 1, which is f of 0.5, and that's about 7.8. So it's about 8, we'll say. And so 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, and 8. So it's about like that. And so it's going to go up to that point. It's going to come back down. And then it's going to hit 1, but it is not going to go through the x-axis. It's just going to bounce back and come up. And this is a good sketch. You'll notice that both ends are up. And it went through the zeros at negative 2 and 0, but not the 0 at 1, because that had an even multiplicity, and when it has an even multiplicity, you don't even cross the x-axis. So, and that should do it for this problem.